presented in the last video of this series. We have in here the casein percentage, the protein percentage found in 5 whey protein samples. The codes of the whey protein samples are in here. And these whey protein samples were analyzed using the LORI in 3 different classes that is shown here. Well, we must compare. We have 5 whey protein samples. The amount of protein in these whey protein samples were the same. The results, the total protein concentration found in 3 different classes were equivalent. We can say that, we can verify this using one-way ANOVA. First, we click in ANOVA. We put your quantitative variable in here. And in here, we are going to separate according samples. We get a p-value that is lower than 0.05. So we cannot say that the 5 whey protein samples has the same protein content. But you cannot say where the differences lies. To see where the differences lies, we must use descriptive plots. We must check confidence intervals. And you can see that this sample, this whey protein samples, has a higher protein concentration, protein percentage than the other samples. Where this one, the sample go, has a lower protein percentage than the another samples. We can see this easily looking to descriptive plots. We already have the rank load plots. We just need to assignate it in here, and you can see the data distribution and box plots. And we already have the histograms in here. So it is easy to see that this sample has a higher protein content than the other samples, where this one has a lower protein content than the others. And this, and these samples have equivalent protein content. Please, every time that I see someone doing one-way ANOVA, they do not check if the data is normally distributed and if the variances are equivalent. So in JASP, you have this command, assumption checks. You must check if the variances are equivalent using the Levene's test. Well, you can run the Levene's test in here and confirm that the variances were equivalent. Test for equality of variances. Now we can do the same thing for the protein percentage determined in 3 different classes. We go to one-way ANOVA, and we select the quantitative variable and we place the days in here. Well, one-way ANOVA shows to us that protein percentages found in 3 different days were not equivalent. Well, we can observe this using descriptive plots. Descriptive plot shows that in the class number 3, a higher protein content was found, a higher protein concentration was found than in class 1 and 2. The protein percentages found in class 1 and 2 were equivalent, but in class 3 were not equivalent. We can do this also using a post hoc tests. We can select days in here and select the post hoc tests in here. For example, if you compare class 1 and 2, all the post hoc tests show that the results are equivalent. But if you compare class 3 with class 1 and class 2 with class 3, we can say that the results were not equivalent, especially if you compare class 2 with class 3. Do not forget to check data normality and the quality of the variance. Clicking assumption checks and look for the homogeneity test, the Levene's test. The Levene's test show that there is a quality of variances. Well, now we have computed the quantitative variable that is casing percentage according to the days, the classes that the samples were analyzed, and according to the samples. But we can do a two-way ANOVA, and we must observe differences between days and samples. So I'm going to place casing percentage in here and select as fixed factors days and samples. Days and samples, the casein samples, the whey protein samples were analyzed during 3 different classes that happened in 3 different days. In here we have the two-way ANOVA. It shows that the protein percentages found were not equivalent, and the protein found in the 5 whey samples were not equivalent. And it already shows that is an interaction between days and samples. Nothing that is the best way to visualize that is using descriptive plots. For example, I place days in separate lines and samples in horizontal axis. I already place confidence intervals, and they can observe in here that there is an interaction between classes and samples, and they can see that there is close results obtained for each sample in the 3 different classes. We can use also rank cloud plots, and the non-parametric Kruskal-Wallis test. We have a rank cloud plots for days and whey protein samples. For example, I have in here the sample C. We have the results found in 3 different classes. We have casein percentage in sample GW. We have the results obtained in 3 different days. We can do rank cloud plots for H whey protein sample analyzing in 3 different days. And we already have the Kruskal-Wallis test. That is a non-parametric test for 2-way and 1-way ANOVA. As you can see here, the non-parametric test shows that protein percentages found in different days and in different classes were not equivalent. So I am showing in the end of this video how to use 2-way ANOVA. It's better you use 2-way ANOVA than 1-way ANOVA. Many thanks for your attention.